Hello friends, let us learn about renewable energy generation systems, wind energy. Wind energy introduction, the energy that can be extracted from the wind and how this varies by location. The wind resource is usually expressed as a wind speed or energy density, and typically there will be a cutoff value below which the energy that can be extracted is insufficient to merit a wind farm development. As a further stage investigations, theoretically wind turbines can be placed in a chosen spacing within a geographical model containing wind speed values as a graded dataset. Geographical Information Systems GIS employing assumptions on the technology conversion efficiency to units of energy. It is possible to derive an energy estimate that corresponds to a defined area. Consideration of technical constraints results in an estimation of technical resources. Consideration of planning, environmental and social issues. Now we can see the block diagram of wind energy. Wind directly lifted into the rotor blades. Rotor blades connected into the gearbox of the system. Gearbox connected into the generator. Wind lifted into these blades. The blades gets automatically starts to rotating. In that rotation, the gearbox and generators will be connected on that hub. So automatically the generation of power will be taken off. Power cables connected into this tower and given to the transformer connected to the switch yards. There are essentially two methods that can be used for the prediction of the long-term wind resource at a site where on-site measurements are available. Method 1 correlate on-site wind data with wind data recorded at a long-term reference station, and method 2 use only on-site wind data. Necessary conditions for an off-site wind data set to be considered as long as term reference are set out below. Reference data set includes data which overlaps with the data recorded on site. It can be demonstrated that the data has been recorded using a consistent system over the period of both the concurrent and long-term data. This should be include the consideration not just for the position and height of the mast and the consistency of equipment used, but also potential changes in the exposure of the mast. For example, the construction of new building in an airport or the erection of a wind farm near an existing mast will corrupt the data. Absolute values recorded at the reference station are not important, but any changes to it in either process or surrounding environment will render it useless as a reference site. This investigation is therefore very important and is usually done by a physical visit to the site, together with an interview with site staff. Exposure of the reference station should be good. It is rare that the data recorded by systems in town centers where the mean wind speed at the reference station is less than half that of the site. So proof to be reliable long-term reference data sets, the data set is well correlated with that recorded at the site. So now we can see some video clips how to form this wind energy systems.
Wind power plant. In this session, we will define wind energy, study the working principle of wind power plant, and learn the application of a wind power plant. Wind energy. Wind energy is the form of solar energy which is produced because of the uneven heating of the earth by the sun. Wind energy is renewable energy and it helps to keep the environment clean. Wind energy can be used for sailing, grinding grains, electricity generation, etc. Let us study the working principle of wind power plant. The important job of converting wind energy into electrical energy is done by the wind turbine of a wind power plant. Let's see how. Unlike the fans, turbines use the wind and generate electricity. The hub and blades are called turbine or rotor. Behind the turbine there is an engine house called as nacelle. The nacelle is mounted on a tower in order to get more wind energy. The wind will cause the blades to rotate. Due to this, the rotor starts moving. As the rotor is connected to the main shaft, it spins the generator, because of which electricity is produced. This electricity can then be transferred by using transmission or distribution lines to homes, industries, schools, hospitals, etc. Let us study the parts of the wind turbine. Let us start with the blades. Wind power plant may consist of 2 to 3 blades. The wind will cause the blades to rotate, which in turn will rotate the generator. Next is shaft. The hub is mounted on the main shaft. The rotation of the blade causes the shaft to rotate. If the wind blows very fast, then brakes can be applied to control the speed of blades and shaft. Next is the gearbox. This can be used to increase the output speed. Next is generator. The high-speed rotating shaft is connected to the generator. Because of this, generator rotates and electricity is produced. This electricity can be stored in batteries and can be used whenever necessary. Applications of wind power plant. The application of wind power plant is to generate electricity. This electricity can be used for many purposes. This electricity can be provided to rural areas where there is a shortage of power supply or no power supply at all. It is easy to establish a wind power plant in rural areas because free wind and space is readily available, and it requires very less infrastructure and cost. In this session, we learnt about wind energy, the working principle of wind power.
I hope this topic everyone could understood. Thank you.